Today we are beginning lesson 8.1, and on day 1 we will do problems 1 through 17 as homework, the odds. There are two primary goals for this first day. First, determine if we can find a formula for a given sequence. So in other words, we have a pattern and we want an nth term formula for that pattern. In some respects we do that by discovery, or compare it to an arithmetic and geometric formula that we already know. The second goal of the day is to determine if the sequence, the a sub n, the pattern, converges or diverges. Converges, of course, means it has a limit, and diverges means there is no limit. And once again, we are referring to the sequence as a pattern, and we're trying to decide what the formula for the nth term does. Does that pattern head toward a number, or does it simply continue to infinity and not head toward a number? We'll do a few examples of each. Tomorrow we'll come back and finish the lesson. The first example is the sequence 1 over 1, 4 over 2, 9 over 4, 16 over 8. So our goal here is to try to come up with a formula for the nth term. Can we find it, the pattern for it? It does help to compare it to the term number. So here n is 1, here n is 2, n is 3, n is 4. And we should see that the numerator is made up of perfect squares, and it does appear to simply be n squared. 4 squared is 16, 3 squared is 9, and so on. The denominator appears to be powers of 2, but we can't simply say 2 to the n. 2 to the 4th would be 16, so this appears to be 2 cubed. Of course, 2 to the 3rd would be 8, and this is only 2 squared. So it appears to be off by 1. 2 to the n minus 1 seems to be the correct formula to represent this pattern. Another example, in a similar fashion, we may have patterns that alternate in sign. So this one is negative 2/3, positive 3/9, negative 4/27, positive 5/8, and so on. Once again, we are trying to come up with a formula for that pattern. We do note that it alternates in sign, and to get a formula to do that, or a pattern to do that, we take negative 1 to a power. We just have to decide if it's the nth power or nth plus 1 power. Again, here, if we consider n to be 1, then it would be negative, and when n is 2, it would be positive, and it does appear as if negative 1 to the n would be correct. Given the first term, third term, the odd numbered terms would be negative. The rest of the pattern appears to be powers of 3 in the denominator, and it does seem as if it's the nth power. And the numerator, again, if we compare it with n is 1, 2, and 3, and so on. It's similar to the n itself, but 1 bigger, and therefore n plus 1 is what we want in the numerator. So some of the problems at the beginning of the homework, you are trying to discover a formula for the pattern. There are two we should review that you know from the past, and that's arithmetic and geometric. An example of an arithmetic would be 5, 8, 11, 14, 17, and so on. So yes, it's arithmetic, and we are adding 3 to get from one term to the next. So that is referred to as the common difference. The pattern from pre-calc was first term plus n minus 1 times the common difference. In this particular problem, the first term is 5, and the common difference is 3, and that would be our nth term formula. If we wanted the 100th term, we'd put 100 in for n, and we'd have the term itself. Again, we should also review from last year geometric. And if we start with 5 and simply double it every time, we should recognize that it's geometric. And we are multiplying by 2 for each problem, for each term. So r is 2. And the nth term formula for geometrics is the first term and the common ratio to the n minus 1 power. So for this one, the nth term formula would be 5 times 2 to the n minus 1 power. The second goal of the day is to determine convergence or divergence. When you are given a particular pattern. So one example might be n cubed over n cubed plus 1. And that itself is the nth term. We could put 1 in there, 2 in there, 3 in there, and write the pattern out. Our question really is, does this thing head toward infinity, or does it close in on a particular value? So yes, we want to take the limit as n goes toward infinity on the nth term formula itself. And then decide if it has a limit or not. You probably recall that we can divide by the highest power of n. So n cubed over n cubed over n cubed, plus 1 over n cubed. Take the limit as n goes toward infinity. First reduce this. We have 1 over 1 plus 1 over n cubed. And when we take the limit as n goes toward infinity, it's true that this piece goes to 0, and the limit is 1. So if we wrote this pattern out, the terms would get closer and closer to 1. In fact, they converge to the number 1. If we look at a pattern given to us in this form, 3 to the n plus 2 over 5 to the n, hopefully we recognize that that appears to be geometric. If we just do a little rearranging, 3 to the n times 3 to the second over 5 to the n, that's really 9 times 3/5 to the n. And it's true that the formula usually has an n minus 1, but we can tell that the common ratio is 3/5. And if we're trying to decide on convergence or divergence, as long as the ratio of a geometric is smaller than 1, absolute value is smaller than 1, that means the terms will in fact converge. And because the ratio is smaller than 1, the terms will head towards 0. So if r is bigger than 1, in fact even equal to 1, generally we say that it's divergent. And actually I might have made a mistake here, because if in fact it would be equal to 1, the terms wouldn't change. And so the terms would stay at that particular number. Probably should flip-flop this around. And yes, it's true that if it's bigger than 1, it diverges. It's slightly different when we're talking about a series where we are adding the terms and questioning what the sum is doing. But geometrics converge as long as r is smaller than 1. Arithmetics all diverge because the terms keep changing and not heading toward a particular value. So it's true that we don't do much with arithmetics because